So nowadays, yes, I am at OSU. Before that, I did spend 15 years kind of roaming around, mostly in the woods in BC, working in the natural resource industries, and I was designing and implementing safety and risk management programs to protect people and protect the environment from these high-risk, high-consequence processes. And as I got further into my career, I recognized that the integration of new technologies into the hazardous processes that we managed, they enabled these systems to operate at greater speeds and at scales, while at the same time they increased the amount of complexity that we faced. And so as a result, it introduces new forms of failure that were increasingly difficult to be able to anticipate, to predict, and ultimately to manage with sort of traditional models of how we manage risk. And yet these models kind of persist. They're largely based on linear causation, like single component failures, and ultimately rely on a human being that should be able to intervene to save the day when things go sideways. And so any of you who've been involved with postmortems or incident investigations know that you often end up, when you're investigating these things, with a lot of data and a lot of complexity that eludes really simple explanations about what has gone on. And you get elaborate, layered stories from the people that are involved in these kinds of events that are about how they're coping with multiple attentional demands in the moments preceding the event, and also the need for this ongoing adaptation to be able to manage that change. And so I went looking for new models, and I largely found that in my work at Ohio State University, some of which I'm going to share with you today. So the sort of rough and dirty roadmap for this talk is I want to spend a little bit of time up front talking about what is it that makes DevOps hard. What are the features of this environment that we, from a sort of systems and a risk or safety perspective, consider quite problematic for people who are tasked with controlling them. And then we're going to take a little bit of a detour to talk about some of the other domains and some of the other industries that we can draw from to both understand how you manage risk and complexity in this domain, but also what we can contribute to those domains by what we learn here. Then I will talk a little bit about coordination and specifically about coordination in the DevOps environment. And then I'll end with what we in the business hopefully call applause. So in yesterday's talk, I used this slide to sort of talk about a grab bag of things, and I want to slow down here a little bit and kind of explore that, because I talked about how continuous deployment in your environment equals continuous change, about these demands for near perfect reliability. When your system becomes valuable to your users, they increasingly depend on it and become less tolerant or less capable of managing inevitable outages that you may experience. Bugs, technical debt, unanticipated interactions. Of course, these things create very difficult to anticipate cascading failures and potentially escalating problems. Some of what we know in the literature about distributed work teams, which is very common practice here, is that this also engenders a suite of additional cognitive burdens and cognitive demands for people working within those systems. And then, of course, things like scale and like architectures, create more known and unknown dependencies for you. So even if you don't have a microservice architecture, you're highly reliant upon the tools and the services that you use to keep your systems up and running. We look at Slack for communicating across distributed work teams or chat ops in general. When these systems may experience, or these tools may experience degraded performance, it can compromise your ability to deal with degraded performance in your system, particularly if those tools, the reliance on those tools, crosses internal organizational boundaries, but also external boundaries into third-party vendors. And so independently, many of these sort of complexities or these challenges in the work have been studied sort of in isolation. But one of the things that's quite interesting of this environment is that there's a whole confluence of these sorts of things coming together. And we know that this imposes cognitive burden for the people that are working within them. So as I talked about yesterday very briefly in the Ignite talk, your expertise largely serves to insulate you and support you in how you navigate much of this. But the time pressure and the increasing uncertainty that's associated with interactiveness in systems means that there's a greater emphasis that we need to engineer these systems, both technical and organizational aspects of this work, to be able to support you to prevent the demands from overwhelming your capabilities. So there's an aspect of this up front that I kind of want to get into, and that is what I'm roughly calling the myth of the fully functioning system. And what we've seen in this domain so far is that most engineers that we talk to seem to think that other companies' systems are very sleek and they're very shiny and they operate all the time and they don't break in weird ways, and that they don't have technical debt like piling up in the back corners, and the engineers are really disciplined and focused about clearing the backlog. And so, you know, those systems in this myth are operating like a finely tuned Audi R8. And it's so pervasive that others have this kind of system. But when we look under the hood and when we get into some of these companies, we see that it's more like the systems look like the chicken bus. And if you've never seen a chicken bus, you know, they're quite common in developing countries, and you know, it's called a chicken bus because you're as likely to be sitting next to a crate of chickens as you are another human passenger. And so in this type of system, you are tying on new features. You're carrying around abandoned baggage code from passengers who got off the bus years ago. And it just kind of keeps piling up, but nobody wants to unload that luggage because it might actually be useful, or you might have other things that are strapped on top of it. And so you're bumping along with all the dents and the cracked windows from the inevitable sort of fender benders that you've gotten into in the past, and you're hoping you don't get a flat because you don't think you have one or you don't have a spare. And so it's kind of an adventure, an anticipation of how things are going to unfold as the world stresses your system and influences your work. And so I went backwards. There we go. My colleague Richard Cook is like much less dramatic about these things than I am, and he states these ideas more concisely. He says that everything in these systems is sometimes broken, that your customers are going to begin to use your products or your services in ways that you never intended, so it's kind of operating outside of its designed for conditions, and it potentially will break. Something is always broken, that you've found a bug and you're sort of waiting for a vendor to fix it. And if nothing seems broken, just wait a minute, because the pace of change is continuous, either from intentional changes or unintentional changes, as your dependent services are making changes to their systems as well. So therefore, recovery, repair, and revision are ongoing, and this is the normal state for these systems. And so this is not an inconsequential point. It's kind of a silly example to use, but the underlying message is actually quite serious, because it doesn't matter how great of a driver you are, you know, the chicken bus doesn't corner the way the Audi does. And if you're working within a system that has constraints that can limit your range of possibilities and your chances of success, that's a problem. So using empirical studies to be able to clearly reflect the actual state of systems, not the way the marketing materials say that it is or the way the playbooks say that it should be, but the actual messy details, that helps us to design for the world that actually is and not the world that could be. And so I threw these slides kind of into the talk last night because largely of what I heard in the open spaces discussion last night. There was stories after stories about the realities of working within your systems, about the messy details of work as done and not of work as imagined. And so this is sort of an effort to reframe this discussion from the, well, we'd be fine if it weren't for, insert broken or degraded component here, to say, recognizing that the normal state of functioning of modern work systems involves some of these characteristics. And so we know this because we have studied real work in a variety of domains, and we are somewhat different as cognitive systems engineers from other forms of research in that we wade into the natural laboratory, into the complexities of real work, in order to understand what is actually going on, not some oversimplified model of how things could be or should be if we just applied a new process or a new tool. And so we use a series of techniques to be able to map out what has happened in past incidents, what kinds of skills and knowledge and capabilities are being brought to bear in different types of situations, and how the changes, the ongoing changes and patterns that we see in these types of systems continue to influence future outcomes. And so in other ways, in other words, what we're trying to do is we're trying to create externalizations of the mental processes and of the cognitive work that it takes for you to operate in these environments. And so I think what's important to emphasize here is that it's not necessarily about building tooling, although that's an aspect of it, but it's about considering the system of work as a whole and looking at how to support the adaptive capacity to be able to cope with these normal fluctuations and variations of the system. And so there's a few other characteristics here that I just want to focus on. One of which is this idea of resource constraints. And typically this is seen as not enough people to be able to do the work. And it can be particularly exacerbated when an organization engages in things like lean practices, because it can inadvertently stress the system by eliminating what appears to be waste or appears to be redundancy on the surface, but in practice might actually be an important source of additional capacity to be able to deal with workload surges or unintended events that come up. And so more often in the digital services community, we see this as being constraints on certain types of people. This could be the veteran developer who held multiple roles within the company and who has a really diverse set of skills, so that she's able to flexibly apply those that knowledge and that expertise into really novel situations very quickly and rapidly. Or it could be an SRE who's able to walk into the middle of an outage and instantly form an understanding of what's going on and have several very promising candidate hypotheses about how do we resolve this and how do we move forward. So another aspect of the systems that we see is multiple competing goals. And so if you are a startup, you might be aggressively growing the business and hiring like crazy, but then you have no time to properly train or orient people to your culture because you're growing so quickly. You might be trying to deploy new features while maintaining the stability of the service, or you might have just suffered a really significant outage and you know that it's important to do a post-mortem to figure out how to prevent this in the future, but you also need all hands on deck to be able to deal with the aftermath of the outage. And so this aspect of system behavior is quite consistent across domains. And to be good at what you do is to be able to handle multiple competing goals in a manner that allows you to reconfigure your priorities to meet constantly changing demands. And so to be competitive in this environment and in this market is to do this better than your peers and over a sustained duration. And so one aspect that's kind of concurrent with that characteristic is how an individual or a company can handle multiple competing demands is how they handle the inherent trade-offs that are associated with those demands. So, how often do we have time or the resources to do a careful analysis of trade-offs from one action to another? And, I did a business degree in my undergrad, and we spent a lot of time learning about these kinds of tools to sort of look at trade-off analysis, and most of which were very time-intensive, and they required a certain amount of certainty in the data that you were using to be able to make these decisions. But in the day-to-day fray of modern work, it's about being able to quickly make sense of the implication of various courses of action, and often with ambiguous data, and to be able to quickly update your mental model of how these trade-offs are going to impact your plan over time. So some of the sources of the trade-offs, that we see are quite common is, it's a sort of a management directive to act in one way over another. There's budget constraints, there's workload constraints, or, you're working with a legacy system that would take extensive effort to move off of, but no one has time for that. So it's kind of patched and tiptoed around, which can often limit sort of future options. So just kind of this brief summary here is that there's features of the modern systems that can challenge expert practitioners. And I would respectfully disagree with my colleague yesterday who was saying that engineering resilience into these systems is not rocket science. Because from my perspective and from 30 plus years of systems engineering, we actually know that it's much more complex than that. And so there's a reason for making these things explicit for you here today. And because part of although these things are like a very real part of day-to-day experiences and normal operations, they're not actually that visible and in the same ways that direct human action or decisions are. And this matters when there's a critical incident where bad things happen and people get blamed for failing to act appropriately. So once something happens, of course, it's very easy to see what was the right choice to make and what the right action could have been. But, when there's an executive on the phone that's sort of demanding to know what happened, or there's legal or contractual liability, the visibility of that complexity and of the difficulties that the practitioners in the moments preceding that event may have been coping with, that just disappears into thin air. And so not only that, but we often lack the language to be able to talk about how these parts of the system actually influence our range of choices given the other competing demands for our attention. And so some of the point of laying all this out is not to stress you out, but rather to widen the lens with which we look at the realities of day-to-day work and to avoid oversimplified explanations about what is going on. And so this necessarily requires us to try and make visible things that are typically in the background and to draw connections between the decisions and actions that may have been made farther away in time and space from those who are immediately sort of preceding an incident, so that we can better understand the way that the system adapts to normal variations of pressures and constraints. And so our lab has been experimenting with ways to represent this for postmortems and for organizational learning purposes. And a large part of my research in DevOps is it points to coordination as being an aspect of modern complex adaptive systems that doesn't get a lot of attention and doesn't really get the attention that it deserves. So coordination is something that we give very little thought to in day-to-day interactions, but it's a very salient example of something that appears quite simple on the surface, but is a much deeper and nuanced phenomenon. So before we get there, I want to briefly touch on some of the things that we've learned from looking at other domains that's also relevant here. And so this is the pit stop. And sometimes, you know, when we talk to practitioners about different domains, we get like a little bit of pushback. They're like, well, that's great, but it's not really relevant, or those examples are too extreme, or, well, we don't operate in 0G. That's true, but there's a couple of points to make here. And one of those is that the unit of analysis that we're looking at is how do people cope with complexity, uncertainty, and dynamic worlds. And your tools are different, and your tasks are different, your goals are different, but there's some common patterns about human cognition in technology-mediated and rapidly changing, resource-constrained, time-bound, goal-conflicted work environments. And so secondly, as we increasingly rely on automation as our sort of co-pilots, or as extensions of our own capabilities and our own cognitive and physical capabilities, it's about understanding how teams of humans and machines can work effectively together. So this means having a reasonably well-calibrated understanding of the capabilities and limitations of your partners. And when we get a new coworker, we do that through dialogue. We find out what have they worked on, what do they know, how comfortable are they with doing different aspects of the work. But this is less readily apparent to us in our automated coworkers. And currently, our automation is very literal-minded, and it's kind of dumb and dutiful, as Earl Wiener put it way back when. So the third kind of piece of this is that when you realize that more and more of our critical global infrastructure, like 911 call routing systems, electronic health records, stock exchanges, air traffic control environments are increasingly dependent on modern digital systems, then I'd say it is pretty darn important that we understand, or we study DevOps engineers and we study this domain to figure out how to be able to support you in better getting those systems back up and running. And it's quite serious work that is worth quite serious study. So, but I promised coordination, so let's get to coordination. And so it is likely that distributed DevOps teams are not going to require physically hurling each other through the air through a sprint cycle, but the choreography between multiple roles in the workflow and the synchronization that's required to smoothly and effectively transition between one aspect of work and another can be thought of as requiring similarly refined levels of coordination as our friends on the screen. And so we coordinate with each other every day, both explicitly, as you did whether you drove here today or even with other people on the SkyTrain, or implicitly. And in Quinn's really excellent talk yesterday, she talked a little bit about the sort of the noise, right? And these were, in many ways, several examples of how coordination has attentional costs. The people that you rely on to accomplish broader goals through joint activity and those automated tools that you use to alert yourself, they can represent significant cognitive burden when they do interact or coordinate with you at points in time that are not relative to the activity that's right in front of you. So I'm going to give an oversimplified example here. And this is an intersection in Hanoi, and there are, engineered aspects of the physical layout of this intersection that enable multiple kinds of actors, buses, bikes, cars, mopeds, to travel in multiple different directions. And each likely has very different goals, but some want to get there faster, some are focusing on safety, and in order to achieve their individual goals, they have to coordinate their actions. So it's assumed here that there's some common understanding of how traffic works and therefore how to anticipate the expected flow of activity to recognize how their own actions must be adjusted relative to the pace of others' actions. And so what we see here is examples of how individual actors will momentarily relax some of their own goals and objectives to better synchronize with the actions of others around them. So there's various forms of sort of signaling that we use to, explicitly turn signal or an eye contact or a gesture that are available in the physical space that may not be available to you in the digital or the virtual space. But with the right lens and the right tools, we can similarly see coordination at work in the digital services domain. So we've talked a little bit here, so coordination, obviously a necessary requirement for any kind of competitive organization, and the complexity and continuous change that's inherent in these modern digital systems requires that multiple diverse knowledge sets are going to be converging for the purpose of detecting, diagnosing, intervening, and monitoring, making changes to the system when it goes down. So this coordination can serve as a protective mechanism to safeguard against further failures and mitigate your impact, but it can also preemptively identify exposures or opportunities to develop new features or enhance the capabilities of users. So let's make this a bit more tangible. We use, in an area where coordination is critical for DevOps squads during system outages, so we use a variety of tools to coordinate with one another. When users may identify that there's an issue, identify a DevOps engineer, they might page out a team to be able to bring together those multiple diverse perspectives. They might also query some of the tools and some of the automated systems. There's interactions and coordinations within the team to be able to assess and understand what's going on. You might be able to, or you might need to reach out to other services that depend on your service that's gone down to let them know what's going on. And oftentimes there's external stakeholders or third-party vendors that have critical information that you need to be able to diagnose what's going on that are outside of your own capabilities. And then, of course, there's always involved stakeholders that need regular updating and communicating on what's happening, how quickly is it going to be resolved, and what's the potential impact for that. And then we also see a lot of coordination costs inherent in keeping management updated on what's going on. So overall, there's a lot of complexity in the coordination that happens in DevOps environments, both internally and externally. So some of the foundations for coordination, and as usually happens when I get started talking about my research, I can't stop. So I am going to have to move quite quickly through this, but my slides will be posted. Some of the foundations that we see for coordination involve that the parties actually intend to work together, and that their work is interdependent, and they recognize those interdependencies. And so it may seem quite self-evident that there's an intention to work together, but these things become much more nuanced and negotiable, fungible, when it is across organizational boundaries. Does your vendor have an obligation or a responsibility to have one of their reliability engineers sitting on a conference call for the entire day to help you resolve your outage? So some of the aspects, the requirements for coordination that we see involve predictability, maintaining common ground, and directability of the agents that are involved in the outage. So in terms of interpredictability, coordination depends on the ability to, or on the capacity to know and predict the actions of other parties with a reasonable degree of accuracy. And therefore, we have a responsibility to make our actions known and visible to people that we are working with. So there's a number of organizational features and personal social features that we use to be able to engender this in real time. In terms of common ground, there's an expected level of mutual knowledge, goals, and beliefs and assumptions about what everybody is capable of doing, their willingness to do those things, and their stance in terms of how much am I going to relax my individual goals to be able to support these broader joint goals. So this is an ongoing cycle to be able to maintain. And then finally, directability is, one of the most understated sort of aspects of coordination, but it's very central to the interdependence of actions. And so directability really refers to that ability to have the deliberate attempts to kind of modify the work of people around you, but also your own willingness to be directed, your own willingness to take instructions from someone else in service of a larger goal. Of course, we see a lot of breakdowns of coordination. In Canada, this is known as the gong show, when things fail. And these are actually really good opportunities for us to understand how does this actually work? Because really well-coordinated work systems, you don't see this effort. You don't see a lot of the sophistication of these kinds of things. So we often study the breakdowns in coordination to be able to see what's important and relevant and necessary. So whether you're landing a 737 at Heathrow, whether you're joyriding with a jetpack out in space, or performing aerial acrobatics, or you're DevOpsing, coordination really matters. And for the DevOps community, as your dependencies grow and as your timescales get compressed in terms of how long you have to respond to things and the criticality of your reliability increases, it's only going to become more important to ensure that coordination is done well. And so in closing, I guess I wouldn't be a good PhD student if I didn't assign reading. So there is, I stand on the shoulders of giants, and I'm hoping that in the future I will be able to be here and share my own research with you in the future. Thank you very much. I do have time for questions. Oh, I explained it all so well, nobody has any questions? Excellent.
How do you reiterate this whole talk for other people to get them on board?
What's the nutshell? Is that what you're asking? Well, I think that there is, sort of as I said earlier, is that we have to avoid oversimplifications, that some of this actually does take careful analysis, it takes careful study, and that's not to say that we don't recognize that you do have a lot going on, and how do we bring other people up to speed, make this relevant and important to them. But perhaps I could say you could join the Snafu Catchers Consortium, with which we do spend a lot of time discussing this, or not a lot of time, but we spend a lot of effort trying to surface some of these things and talk about them in a group of peers. There are no easy answers. Yeah?
Do you find there's a difference between, say, large companies and small companies with respect to
interpredictability?
Yes,
Yes, I mean, as the number of sort of components or people or agents that you have to sort of coordinate with grows, of course, you're going to get increasing levels of complexity. But you can have smaller organizations that have, they're running a service that is critical to many other operations. And so those coordination requirements are quite complex in and of themselves. But there is variability in sort of how this plays out for sure. You've been, oh, one more.
Just thinking about that intersection and what happens if somebody just stops right in the middle?
Okay,
Just rockets through. And
right.
how do you do it with post-mortem or something like that?
Right. So the question was, what do you do, in the intersection if somebody stops or, rockets through? There you see coordination breakdowns. So you see this sort of like normal fluidity of work and work processes get disrupted. So what happens is other people have to adapt and have to adjust to that kind of action. And so there is always going to be people or situations that do rocket through the intersection. And so the ways in which your system is able to absorb that and to be able to absorb that in a way that doesn't detract from performance on other kind of areas, that's really what we're quite interested in. That's what we see as being the resilience of the system. Excellent. You've been a fantastic audience. Thank you.